Hello guys, we have a problem here, problem number 2, and it starting with the copper metal. Describe how to prepare copper 2 carbonate. The first question you ask yourself is this carbonate or the salt we are told soluble or insoluble. So all carbonates are insoluble except sodium carbonate, potassium carbonate, and ammonium carbonate. So the first thing, because it's copper metal, it's not going to react with dilute acids. Therefore, you must heat it in air. So the first thing here, you say heat copper metal. Heat copper metal in air to obtain, you heat it in air to obtain copper 2 oxide. So the first thing, you heat copper metal, which is you heat in a crucible, maybe copper solid plus oxygen gas. So it's going to give me copper 2 oxide. So I've used the equations to explain it. So balancing the equation, oxygen is 2, oxygen is 1. So we put 2, oxygen to be 2, copper is 2. I put a 2 here. So that is copper 2 oxide. That is how we start, because you cannot react copper metal with dilute acids. So you must heat it in air. So lead and copper, you must heat them in air to obtain their respective metal oxide. But other metals above hydrogen in the reactivity series can be prepared by reaction of an acid and a metal. After that, add excess copper 2 oxide that is formed. Add excess copper 2 oxide to dilute. You can use dilute nitric 5 acid, you can use dilute hydrochloric acid, or dilute sulfuric acid, because it will form a respective soluble salt. So add excess copper oxide to dilute. I love using nitric 5 acid because all nitrates are soluble. So add excess copper 2 oxide to dilute nitric 5 acid to obtain, or you must filter so that to remove unreacted copper 2 oxide. So add excess copper 2 oxide to dilute nitric 5 acid and filter to obtain copper 2 nitrate as the filtrate. Copper 2 nitrate as the filtrate. So add excess copper 2 oxide to dilute nitric 5 acid and filter. So filtering is to remove unreacted copper 2 oxide. So and filter to obtain copper 2 nitrate as the filtrate. Now this filtrate, before we continue, so it's copper oxide solid plus HNO3 aqueous is going to give us copper nitrate, a soluble salt, or you can use sulfuric acid to give us copper sulfate, or you can use hydrochloric acid to give us copper chloride, which is soluble. So plus water. So balancing the equation, N is 2. So I put a 2 here. Then 7, so the equation is balanced. So after that, you have this soluble. This is the filtrate. Now this is the filtrate. So what do you do to the filtrate? You mix the filtrate with a soluble carbonate. So mix the copper nitrate, which is the filtrate. Mix copper nitrate. Yes. Mix copper nitrate with a soluble carbonate, of course, potassium. Let me use potassium. Mix copper nitrate with potassium carbonate, which is soluble, to precipitate out copper carbonate. Mix copper nitrate with potassium carbonate to precipitate out copper carbonate. then you do what? Then after that, filter to obtain it as the residue. Filter to obtain it as the residue, and wash it between filter papers to obtain crystals of copper carbonate. To obtain crystals. So mix copper nitrate with potassium carbonate to precipitate out copper carbonate. Mix copper nitrate with potassium carbonate, which is soluble, to precipitate out copper carbonate. Filter to obtain it as the residue, and wash it between filter papers to obtain crystals of copper carbonate. So equation will be copper nitrate aqueous plus potassium carbonate aqueous is going to give us copper carbonate solid plus potassium nitrate aqueous. So balancing the equation, I put a 2 here, I put a 2 there, and my equation is balanced. And ionic equation, ions that undergo change, will be copper ions aqueous plus carbonate ions from potassium carbonate aqueous to give us copper carbonate, which is a precipitate solid. And that is how we prepare insoluble salts. So heat copper metal in air to obtain copper 2 oxide. Add excess copper 2 oxide to dilute with 5 acid and filter to obtain copper nitrate as the filtrate. Then you mix copper nitrate with potassium carbonate, which is a soluble salt, to help us precipitate out an insoluble salt. Thank you for listening to me, and make sure you subscribe to my channel so that we can support the fire burning of chemistry. Thank you. Your chemist, Michael Moruri.